US airstrikes in Somalia's Golis Mountains killed key ISIL figures.
Moving on to East Africa now, where US airstrikes launched a major operation against the Islamic State in Somalia.
The US military claims 60 terrorists have been killed in recent operations.
In a matter of seconds, 12 FA-18 Super Hornets launched from the USS Harry S. Truman unleashed a coordinated strike on a mountain stronghold in Somalia. The operation was executed with real-time targeting data and sustained by mid-air refueling, demonstrating the reach and tempo of modern carrier-based air power. At the heart of the mission was the BLU-109 bunker buster, engineered to penetrate 8 feet of reinforced concrete before detonation, delivering a level of precision and destructive force rarely seen in contemporary conflict. But why was this remote mountain chosen? And what made it such a priority for US forces? To understand the significance of this target, we need to examine the strategic threat it posed to the region. The mountain complex in the Golis Mountains stood as a fortified hub for militants orchestrating attacks across Somalia and neighboring countries. Intelligence reports pinpointed this location as a nerve center where operations were planned, logistics coordinated, and weapons stored. The cave network, carved deep into the mountain and reinforced with thick concrete, exploited the natural protection of the terrain. Entrances were concealed, and the interior tunnels took advantage of both the geology and added man-made fortifications, creating a defensive stronghold that challenged conventional military approaches. This site's strategic value was rooted in its ability to provide a secure base for militants to organize, train, and launch operations with minimal risk of detection or disruption. Surveillance indicated a steady flow of fighters and weapons in and out of the tunnels, with evidence of training camps and stockpiles intended for future attacks. The network's remote location further complicated any attempt to monitor or intercept these activities, allowing militants to operate with a level of impunity rarely seen in the region. The physical defenses of the Golis stronghold were formidable. Steep, rocky slopes and limited access routes made the approach hazardous for ground forces. The cave entrances were expertly camouflaged, blending into the landscape and shielding the interior from aerial observation. Inside, the labyrinthine tunnels and reinforced chambers created a complex that could withstand indirect fire and most conventional munitions. This combination of natural and engineered defenses mirrored tactics seen in other conflicts, such as the Tora Bora cave systems in Afghanistan, where militants used similar terrain to evade and resist even the most determined assaults. Previous assessments made it clear that a direct ground assault would have resulted in significant casualties. Any attempt to breach the mountain by force would have exposed troops to well-defended choke points, sniper positions, and improvised explosive devices. Even if ground forces managed to reach the entrances, the fortified tunnels would have remained largely intact, allowing defenders to regroup and counterattack from within. The risks were compounded by the possibility of ambushes, the lack of reliable intelligence on tunnel layouts, and the sheer difficulty of moving heavy equipment through such treacherous terrain. The US military recognized that overcoming these obstacles required a shift in strategy. Rather than attempting to storm the stronghold, planners focused on neutralizing the site's strategic value through precision airstrikes. The goal was to collapse key sections of the cave network, destroy weapons caches, and deny militants the ability to use the site as a base of operations. Achieving this required a combination of accurate intelligence, advanced munitions, and aircraft capable of delivering those weapons deep into fortified positions. The decision to target the Golis Mountains with air power was informed by detailed reconnaissance and analysis. Satellite imagery and signals intelligence mapped out entrances, defensive positions, and suspected command centers within the mountain. Analysts confirmed that the militants relied on the reinforced concrete and natural rock to shield themselves from conventional attacks, betting that their defenses would hold against anything short of a full-scale siege. However, the introduction of specialized munitions, specifically the BLU-109 bunker buster, shifted the balance. Designed to penetrate up to 8 feet of reinforced concrete before detonation, the BLU-109 offered a way to reach deep into the mountain's interior and neutralize hardened targets. Executing such a strike demanded more than just the right weapon. It required an aircraft with the range, payload, and precision to deliver the munition accurately on a remote, well-defended target. The FA-18 Super Hornet, with its carrier-based deployment, extended loiter time, and advanced targeting systems, was uniquely suited for this mission. Its ability to operate in contested airspace, coordinate with other assets in real time, and deliver bunker-busting ordnance with pinpoint accuracy made it the logical choice for the operation. The destruction of the Gola stronghold sent a clear message about the evolving nature of modern conflict. No matter how well defended or remote a position may be, advancements in intelligence, targeting, and munitions can overcome even the most daunting fortifications. The operation demonstrated that the combination of technology, training, and tactical innovation could neutralize threats that once seemed untouchable. As the focus shifted from identifying the threat to executing the strike, attention turned to the aircraft and weapons systems that would make such precision possible. Most notably, the FA-18 Super Hornet and its specialized payload. Among the US Navy's most capable assets, the FA-18 Super Hornet is engineered to deliver both versatility and precision in demanding combat environments. This carrier-based fighter is designed for dual roles, excelling in both air-to-air engagements and ground attack missions. Its adaptability was essential during the Somalia operation, where the mission required penetrating a heavily fortified mountain base. The Super Hornet systems and payload options allowed it to confront entrenched threats, delivering targeted strikes without sacrificing flexibility or operational tempo. For the Somali mountain strike, the Super Hornet's payload capacity proved critical. Able to carry up to 17,750 pounds of external weapons, the aircraft was equipped with a 2,000-pound BLU-109 bunker buster. This specialized munition, featuring a hardened steel casing and a 535-pound explosive charge, is designed to punch through up to 8 feet of reinforced concrete or 200 feet of dense earth before its programmable delay fuse triggers detonation. This internal explosion ensures that the destructive force is concentrated inside hardened structures, collapsing tunnels and eliminating command centers that would survive a surface blast. The BLU-109's engineering makes it especially effective against underground complexes like the Golas cave network, where traditional munitions would have little effect. Precision in targeting was just as important as raw firepower. The FA-18's ASQ-228 advanced targeting forward-looking infrared system gave pilots the ability to identify and track targets from beyond 40 nautical miles. ATFLIR's high-resolution thermal imaging distinguishes between combatants and civilians by detecting subtle differences in heat signatures, even through smoke, dust, or camouflage. This capability was vital for the Somalia mission, where militants used the terrain and environmental cover to mask their positions. The system's ability to pick out individual figures, differentiating armed personnel from non-combatants, helped minimize collateral damage and ensured that each strike was both lawful and effective. The ATF LIR system's laser designator further increased accuracy. Once a target was identified, the laser could mark precise coordinates, enabling the BLU-109 to be guided to within a meter of its intended impact point. In the context of the Golas Mountain, this meant that the Super Hornet could deliver its payload deep into the cave system, neutralizing threats hidden beneath layers of rock and concrete. The combination of standoff range and pinpoint guidance allowed the aircraft to remain outside immediate danger while maintaining total control over weapon delivery. Operational flexibility set the Super Hornet apart from other platforms considered for the mission. Its combat radius of 449 nautical miles allowed it to reach remote targets without extensive logistical support. The aircraft's ability to refuel mid-air, extending its time over the target area, ensured continuous presence during the operation. This feature allowed pilots to respond rapidly to emerging threats, coordinate multiple attack runs, and adapt to changes on the ground in real time. Versatility extended beyond weapon delivery. The Super Hornet systems enabled real-time data sharing with command centers, intelligence analysts, and other aircraft. This networked approach ensured that information gathered during the strike, such as the movement of militants or the location of secondary targets, could be acted upon immediately. As the operation unfolded, pilots received updated coordinates and intelligence, allowing them to pivot from the initial bunker-busting strike to tracking and engaging fleeing fighters attempting to escape through the surrounding terrain. The FA-18's design reflects a balance of power, adaptability, and technological sophistication. Its dual-role capability, advanced targeting systems, and ability to sustain extended operations made it the platform of choice for missions where both precision and endurance were required. The Somalia strike highlighted how these features come together in practice. The aircraft delivered devastating force against a fortified target, then seamlessly transitioned to follow-up actions as the situation evolved. The events over the Golas Mountains illustrated how technology and human skill intersect in modern warfare. The Super Hornet systems provided the tools, but it was the pilot's expertise and the coordination with intelligence assets that ensured the mission's success. The operation did not end with the collapse of the mountain base. Instead, the aircraft's real-time adaptability allowed it to immediately target those who tried to escape, setting the stage for a strike sequence that would unfold with remarkable speed and accuracy. What followed was a demonstration of how months of planning, advanced munitions, and real-time intelligence converge in the execution of a precision strike deep in hostile territory. The operation's critical phase began as the Super Hornets approached the Golas mountain complex, maintaining radio silence and low altitude to avoid detection. Intelligence and mission planning had mapped out the fortified cave entrances, with each jet assigned to a specific target. Ground spotters, likely special forces embedded near the perimeter, readied laser designators to guide the munitions. The pilots, relying on real-time updates from command centers and intelligence analysts, coordinated their approach with precision. Every element of the strike depended on seamless collaboration, from the analysts monitoring enemy movement to the pilots navigating hostile airspace. The terrain concealed the true scope of the underground facility. Reinforced concrete and natural rock protected the cave network, with entrances scattered across steep slopes. The need for accuracy was absolute. Missing a key entrance or striking an unprotected area could leave the stronghold operational. The FA-18's AASQ-228 advanced targeting FLIR system enabled pilots to detect faint thermal signatures through gaps in the rock, identifying engines, weapons caches, and human activity. This data fed directly into the targeting process, allowing laser designators to mark precise coordinates for each strike. At an altitude of 4,200 feet, the first wave of Super Hornets released their BLU-109 bunker busters. Guided by laser, each bomb followed a calculated path, adjusting mid-flight to home in on its assigned entrance. The BLU-109's hardened casing allowed it to penetrate deep into the reinforced cave system before its programmable fuse triggered detonation. Instead of a surface explosion, the bomb's delayed blast occurred inside the mountain, collapsing tunnels and command centers from within. As the munition stores inside the caves ignited, Secondary explosions rippled through the complex, amplifying the destructive effect and ensuring the network's infrastructure was neutralized. From the air, the initial impact appeared subdued. Minimal surface disruption, no immediate fireball. Pilots monitored the aftermath through their sensors, watching as plumes of smoke and dust vented from hidden shafts and entrances. These secondary blasts, ignited by the detonation of stored ammunition, confirmed that the bombs had reached their intended depth. Real-time sensor feeds and secure data links allowed pilots to relay confirmation back to command centers, where analysts quickly cross-referenced strike results with pre-mission intelligence. The stronghold's operational capability was effectively erased in minutes. A brief moment of uncertainty followed the strike. With the mountain complex collapsing, intelligence indicated militants were attempting to escape through concealed exits. The Super Hornets, some running low on fuel, faced a decision point. Rather than break off to refuel at distant bases, the pilots activated the buddy refueling system. One aircraft transferred fuel mid-air to another, allowing the strike group to remain on station and respond to emerging threats without delay. This maneuver preserved the operation's momentum and ensured continuous pressure on the enemy. Live thermal feeds from the AT/FLIR systems and secure data links enabled immediate retargeting. As fleeing figures were detected moving through rocky terrain, updated coordinates were shared across the strike group in real time. The networked targeting capability allowed multiple aircraft to coordinate follow-up strikes, guiding laser munitions onto moving targets with precision. The combination of advanced sensors, rapid data exchange, and pilot skill left little opportunity for escape. Each engagement was executed with the same focus on minimizing collateral damage and maximizing operational effect. The adaptability and precision demonstrated during the strike underscored the changing nature of air power. The mission's success relied not only on advanced munitions, but on the integration of intelligence, technology, and flexible tactics. The Golis mountain base, once a major node for regional militant operations, was rendered inoperable. The strike's outcome extended beyond the destruction of a single target, raising questions about the broader implications for military strategy and the balance of power in the region. The impact of the Golis mountain strike was immediate and measurable. Satellite imagery captured in the days following the operation showed a complete lack of movement in and around the former stronghold. Where analysts once tracked regular activity, vehicles, supply transfers, and personnel, there was now only silence. Intelligence reports documented a rapid decline in coordinated enemy communications and operations in the surrounding region. The collapsed tunnels and destroyed supply caches severed critical lines of logistics and command, leaving militant groups unable to regroup or sustain operations at previous levels. The effect was not just tactical, but systemic. The loss of the mountain complex disrupted years of effort invested in building a secure, concealed hub for regional attacks. This outcome was the result of a deliberate shift in US military doctrine. Rather than committing ground forces to a costly and dangerous siege, the operation relied on the projection of air power from the sea, advanced targeting systems, and precision-guided munitions. The use of the BLU-109 bunker buster, delivered by Super Hornets operating from the USS Harry S. Truman, allowed planners to eliminate a hardened target with minimal risk to personnel and without the need for local basing or overflight permissions. The A/ASQ-228A TFLIR targeting system enabled pilots to identify and engage concealed threats from standoff distances, closing escape routes and ensuring that the strike reached its intended depth and effect. This blend of technology and operational flexibility exemplifies the broader US transition towards surgical strikes, actions designed to achieve maximum impact with a minimal footprint. The strategic value of carrier-based air power was underscored throughout the operation. By launching from international waters, the Navy maintained operational independence, free from the constraints of fragile alliances or local politics. In regions like East Africa, where access to land-based facilities is often uncertain, this mobility provides a decisive advantage. Carrier strike groups can deploy air assets, sustain operations, and deliver precision strikes hundreds of miles inland, reshaping the security landscape without the vulnerabilities associated with forward-deployed ground forces. This capability is central to current US doctrine, prioritizing agility, global reach, and the ability to act unilaterally when necessary. The destruction of the Golas cave network also sent a clear message to adversaries and observers. The operation demonstrated that even the most remote fortified positions are vulnerable to precision targeting and advanced munitions. The analogy is apt. The strike functioned like severing a critical artery in the enemy's network, halting the flow of resources and coordination that sustained militant operations. Maps of the region now mark the site as neutralized, a void where a vital node once operated. The sudden loss of this hub left enemy forces fragmented, their ability to coordinate and launch regional attacks effectively erased. For those relying on geography and fortification as shields, the operation stands as a warning that technological superiority can overcome even the most formidable natural and engineered defenses. Potential retaliation was a concern for planners, but intelligence in the aftermath indicated only scattered, small-scale attempts at reprisal. No significant counterattack materialized, though vigilance remained high for isolated incidents. The rapid collapse of the enemy's command structure limited their capacity for organized response. This outcome further validated the strike's precision approach. By eliminating the central node, the operation reduced the risk of immediate, large-scale escalation, while maintaining pressure on remaining hostile elements. The implications of the Somali strike extend beyond the immediate tactical victory. It provides a model for how future operations can leverage long-range air power, advanced sensors, and precision munitions to neutralize hardened targets in contested or inaccessible environments. The mission's success highlights the increasing reliance on carrier-based assets to project force globally, independent of ground access or local partnerships. As adversaries adapt by dispersing and fortifying their positions, the ability to identify, target, and destroy critical nodes from a distance will become even more central to US strategy. This operation stands as a blueprint for the next generation of grey zone missions, those that require decisive action without large-scale deployments or prolonged engagements. The lessons drawn from the Golas Mountain strike will inform how the US Navy and its partners approach emerging threats, balancing technological innovation with operational discipline. As the landscape of conflict continues to evolve, the integration of precision air power and advanced targeting will define the contours of military strategy moving forward. This operation over Somalia demonstrated how US power projection has changed. Precision munitions like the BLU-109, advanced sensors such as ATFL-IR, and operational flexibility, including buddy tanking, combined to eliminate a fortified target once thought unreachable. The strike addressed a complex problem with a focused solution, showing how these capabilities now shape the outcome of high-risk missions. No fortified hideout remains safe when technology, training, and real-time coordination converge. If you want more detailed breakdowns of modern military technology, subscribe to the channel. Let us know in the comments which aspect of this operation, munitions, sensors, or tactics surprised you most.